All right, hello, and thanks for tuning in. Today, I wanted to cover a little bit more on ggplot. So we introduced ggplot, and we explored a little bit about creating some data visualizations. And I wanted to cover two more geometric objects, and there are many different geometric objects that you can use in ggplot, but some important ones are the column and the line geometric objects. So let's just go ahead and take a look. And so we'll take a look at geom underscore column and geom underscore line. A lot of the material comes from our textbook, Modern Data Science with R, which you can read. And then also there are a lot of content that I'm taking from the R graphics cookbook, which you can also read in your browser. And so yeah, please make sure you do your reading from the textbook, and then use these as references, the R graphics cookbook. Okay, there is a full list of all of the different geometric objects that you can use in ggplot. There are a lot, and but yeah, probably some of the more common ones will be the point and the columns and the lines. And then there's also this PDF, which is a cheat sheet, and I highly recommend it. It shows a whole bunch of the different kind of geometric objects that you can use in ggplot, and it lists off some of the different aesthetic attributes that can be tied to a variable or mapped to a variable, or things that you can set. And then just like anything else, if you have more questions, you can go online and search for help. Okay. A lot of the examples will be using some data sets coming from this library, the G Cookbook, Graphics Cookbook Library. And so just like any other package, if you don't already have it, you'll have to do install.packages of the package. And again, you only do that once. And you want to make sure you're not doing install.packages in your RMD file or something like that, okay? So you only need to install the package once, and then once you have it installed, then you call library to basically access it. So you will need to call library every time in your RMD file, but make sure you're not doing install.packages in your RMD file. Okay, but let's go ahead and take a look at bar graphs here. All right, and so in this example, I have just a very simple table. There's only 3 entries here, and we have basically one of the columns is going to be like a categorical variable, which is going to be kind of like the position that we're going to put on the x-axis. So here our categorical variable is, we have the control, treatment 1, and treatment 2. So you can imagine this kind of being like a summary table from some experiment. And then the other column is the numeric value that we want to plot. Okay, and so this will be tied to the height of each bar. And so in this case, if the value is directly tied to the height of the bar, we will do a geom underscore column. Okay, and this will add a column geometric object. And then the aesthetic mapping is we are going to tie the y position, okay, to that numeric variable. So I have the x position tied to the group. So control, treatment 1, and treatment 2 goes into the x position. And so ggplot says control goes over here, treatment 1 and treatment 2. The default is just to put them in alphabetical order. And then the height of the bar is associated with the weight variable. Okay, so I have weight, and so control has a height of 5.032, treatment 1 has a height of 4.661, and treatment 2 has a height of 5.526. Okay, so that's going to be here, and we have plus geom underscore column plus theme underscore black and white. Theme underscore black and white just kind of colors this. The default, I think, is the background is gray, and just for this presentation or slide deck, I've just chosen theme black and white for this. But this is kind of the default. settings. There are other aesthetic attributes that you can change. Okay, and so here I have just the settings, and but you can just like anything else, you can tie these kind of aesthetic attributes, and if you put it inside AES, then it will be associated, it will be mapped to a variable. But here we're just doing a setting, and so fill is going to be the fill color of the bar, and then color is going to be kind of the outline color. So you can kind of change the outline color and whatnot. You can also change the thickness of the line. The line weight is 2, and that's going to be the thickness of the line. Right now these are just settings, so all 3 bars have the same settings, but you know, if you had another categorical variable, you could have the fill reflect that or something of the sort. So these are just some of the other kind of things that you can change with a for a geometric object, for the kind of column geometric object. Okay. Other things you can do is you can also change the width of the bar. The default is that the width of the bar is 0.9, 90%. Now you could set the width equal to 1, and that eliminates any kind of gap in between the bars. Okay, and then you can set it to something less, say width is 0.5, and that makes your bars thinner. And again, if you put width inside AES, then you could have the width of the bar tied or mapped to some, you know, data attribute, some variable that's in the data. Okay, some kind of numeric value. A lot of times we have multiple categorical variables, and we want to plot this. Okay, so we'll tie the numeric value to the height of the bar, and then we'll map the categorical variable to X, and we'll map the other categorical variable to, say, the fill color. And as far as some options we have, we can choose our positions to be dodge, stack, or fill. Okay, and so I just want you to kind of pay attention to what happens as we map some of these things out. All right, so you could imagine there are I guess 2 sales teams, and we have team A and team B, and we have the numbers recorded for Wednesday, Friday, and Saturday for both teams, and we have kind of the sales figures recorded for each of these things. Here we'll do this. We could have just left it as Wednesday, Friday, Saturday as kind of a character vector. Factor basically tells R specifically this is a categorical variable, but you know, don't worry too much about it. Okay, so here I'm going to put on the X position basically the day of the week. So our 3 values for day of the week is Wednesday, Friday, Saturday. So that's going to be the position. Okay, and then as far as the color, the fill color, we have teams. So we have team A and team B. And then we are going to choose for the positioning dodge, and this means the bars I guess dodge each other, just get plotted side by side. Okay, the height of the bar reflects the sales figures, and so we can see on Wednesday and Friday team A outperformed team B, and then on Saturday Team B just ever so slightly outperformed Team A, but this is kind of the comparison that we have here. Okay, other options that we have, okay, is I could map the team to the x-axis, and now I'm going to have Team A over here and Team B over here, and then I can say the fill color will be the day of the week, and so now I have 3 fill colors. I've got Wednesday, Friday, and Saturday, and it gets plotted out this way. So again, 2 very similar, so the exact same data, okay, and the commands are very similar. However, just kind of by switching which variable goes to X and which variable goes to fill, all right, so the commands are similar, but the resulting graphs, I think, are quite a bit different. Now, what is it that you want to kind of what is the story you want to tell? Okay, I believe this will show a direct comparison between A and B. Okay, so you see the red is higher than the blue, red is higher than the blue, and here they're kind of, so here we're kind of comparing these. Okay, whereas over here, I think the thing that we're trying to show is that sales figures over the days of the week, basically Wednesday has the worst, and then we have Friday and Saturday and we kind of see sales go up as we go Wednesday, Friday, Saturday, Wednesday, Friday, Saturday, sales go up. So I mean, that's what I'm perceiving when I see these bar plots. And you know, generally you'll probably want to have some kind of line explaining what it is that you're trying to draw attention to. These are other options. Okay, so here we have stacked bar plots. So again, same data, all right? And here I have on the X date. So again, similar to this, except here the position is Dodge, okay? And here the position is stack. And so the A figures are stacked on top of the B, and so on and so forth. And so here it becomes a little bit, it's more difficult to tell the difference between how much more A is versus B, right? Over here, you can compare the heights very clearly. Over here, if I said, hey, which one is bigger, red or blue? I think that's, or red or teal, I think that's difficult to tell, okay? Here, I think maybe you can kind of eyeball it, but it's not so easy. The clear thing that's being communicated here is that Wednesday is the shortest, then Friday, and then Saturday, and then you kind of have, the distinction between what's happening with Team A and Team B is, I would say, you're not drawing as much attention. You are saying like there are different kind of components, and they both kind of make up for that, but it's not a direct comparison like this. Here, same kind of thing where we're stacking it, except we have Team A and we have Team B, and so now you can see the total sales of Team A versus the total sales of Team B. The color is Wednesday, Friday, Saturday, so you can see, both of them have Wednesday, Friday, Saturday, but again, now how much greater is Saturday versus Friday versus Wednesday? That's really difficult to tell, okay? When they're all stacked on top of each other, how different they are is difficult to tell, but here we can now see the thing that's very clear to us is that the total sales of A is greater than the total sales of B. And we have three parts, Wednesday, Friday, Saturday, but distinguishing between how much is where, that's kind of difficult, okay? Here, if you want to kind of bring emphasis to the proportions, you can do this, and you can do position equals fill, and what this will do, okay, is you get the stacked, basically the stacked bar, except the stacks add up to 100%. So now we lose the exact kind of, you can't compare, so it's basically this, but we're stretching all of them to have the same height. So, here we have the stacked of A and B for Wednesday, but the total is, I don't know, 400 something, and here the total is 500 something, and the total here is 600 something. But when you have this, the total is all 100. So you lose the exact numbers. But what becomes clear is the proportions. And so now you can see B is under 50%, B is under 50%, and here B is just slightly over 50%. The line for 50% is very faint, but it is there, and you can see B is slightly over 50%. So here you kind of see the change in the proportions. That is what is being communicated in this plot. Okay. Similarly, we can do it with A and B here, and again, what becomes clear is that for Team B, the Saturday sales figures are greater than Team A's Saturday sales figures. But yeah, it's a little bit harder to tell, but these are stacked bar charts, and the proportions are there. Okay, I forget. I don't think I've given you any view quiz answers. Let me give you your very first one First view quiz answer today is the letter A. A as in apple is your first view quiz answer. A as in apple. Okay. So that is just some of the different examples, and these are quite a few plots that we created just from the exact same data set. It's just we had two categorical variables, team A and B, the date, and some numbers here. So we basically have three variables, and we had all kinds of variants of these plots. Okay, here is another data frame, and this one this data frame is called U.S. population change, and it just measures, it compares the census numbers from 2010 with the census numbers from the year 2000. I wish we had a more updated one with census numbers from 2020, but unfortunately that is not this data set. And what we've done is we've taken this variable change, which is, how much did the population change from the year 2000 to the year 2010, and we sorted them in descending order, okay, and we're just looking at kind of the top 10 states. So Nevada had a huge increase in population, increased by 35% between the year 2000 and 2010, and I think it's still one of the fastest growing states. Las Vegas is growing very quickly, and now they're getting all kinds of professional sports teams and things like that. Okay, Arizona also had major population growth. Utah, things like that. We have colored, or not colored. We have looked at the region. Okay, and at least for the top 10, we have the West and the South regions represented here, and then here are the state kind of abbreviations. So just for now, we'll kind of just plot this, all right? And so here I'm going to still kind of use the column geometries, and what we're going to do is we're going to plot the variable change here on the y. So the height of the bar is going to represent change. We're going to put abbreviation along the x-axis, and again the default order is to put in alphabetical order. So we have AZ for Arizona over here and UT for Utah over there. And then we have the fill color of these things tied to the region. And so West is in the teal and South is in this kind of reddish color. And this is what our plot looks like. There's a few things we can do this. Do with this. So one is, if I wanted to draw extra emphasis to the change variable, I can map the change variable to both the height and the fill color. Okay, and so now we can see Nevada with the highest growth change. Its color is the brightest at 35, and South Carolina, which is number 10. Okay, so still showing a lot of kind of population growth, but limited it to just the top 10. It gets colored with a darker color here. Okay. Again, further emphasis to this is we can rearrange. Okay, so the default ordering is to put them in alphabetical order, okay, along the x-axis. But what we can do is we can arrange them in the order of a numeric variable. So in our case, we can say x is going to be the abbreviation, but reorder them according to change, okay, according to the change variable. And so now the change variable shows up in all three of kind of the aesthetic mappings that we have. So from left to right, change is represented with the greatest amount of change on the right and the least amount of change, at least for the top 10 on the left. We have the color, the fill color, mapped to change, and so we have the darkest color over here and the brightest color over here, and I think our eyes are drawn to kind of the stark contrast between the bright blue and the next shade of blue here, and we can see there's kind of a gradual shift here from dark to bright, but then there's kind of a jump in brightness between Arizona and Nevada, and then also the height of the bar. So we're really just trying to draw a lot of emphasis to this, and probably highlighting even more just how much higher this variable is for Nevada change value is than any other value. And so we can see, yeah, Utah and Arizona had similar values, but there's a big jump between number 1 and number 2 in this list here. So these are some of the options. Okay, other things you can do. So here, earlier we had these colors, and ggplot automatically picks the colors, and we had south and west, and so we have these kind of 2 colors here. If you wanted to, you can pick out your own colors, and you can do that by choosing something like scale fill manual on how what values you want to use for fill color, and I think these are the official hex codes for UCLA colors, for the blue and the yellow, or blue and gold for UCLA colors. But yeah, you can pick out any kind of things. You can use to named colors, which like, was it chocolate or something, chocolate 4, and blue, there's different shades of blue and forest green, just different names, or you can use hex codes as well for your colors there. Here we can do going back to this, the default for gradient is ggplot picks kind of a dark shade of blue and a bright shade of blue here, but if you want, you can pick different shades, and you can say on my gradient, my fill gradient, on the low end I want the color red, and on the high end I want the color blue. And so if everything was kind of smooth, we would go from red to kind of purplish or magenta to blue, and here we kind of go from red to magentish, but then there's a big jump between here and blue, and so we don't have the smooth transition there. But if we had more values in between, we would see a smoother transition. And again, this is just some of the custom values that you can use. All right. Sometimes you have a big data set, and you want to kind of summarize a categorical variable by graphing the counts of each category, okay? And in this case, we will use the geom bar, okay? And this, when you do this, you don't map any aesthetic value to y. This is going to be the height of the bars will be handled by R and ggplot. Okay, let me go ahead and give you your second view quiz answer. Second view quiz answer is the letter B. B as in bear, B. Okay. And so here, again, geom bar, but don't map anything to the y variable. And when you do this, ggplot will go through your table, count how many times each category appears, and use that as the height of the bar, okay? And so one of the data sets available to us is this diamonds data set, where they gathered a whole bunch of information about, I guess, diamonds. And if you ever go diamond shopping, there's a few different values and variables that are of interest. And one is how big is the diamond? That's the carat. It's like the weight of the diamond. Diamonds are cut by professionals or machines, and then they're graded on the cut. And so you can have like ideal cuts and good cuts, very good cuts, or fair cuts, and things like that. Diamonds are also graded on color, where I think D is the best color, and that's like perfectly kind of colorless. But then, diamonds can also have other tints and things like that. And so if the diamond is kind of yellowish, it gets a lower color grade. There's like clarity. If there's little specks of impurities in the diamond, then the clarity grade goes down. And so these variables where there is an order, it's a categorical variable, but there's an order to them. These get labeled as ordered variables or ordinal variables. So it's kind of like shirt sizes, small, medium, large, extra large. That's kind of the order that you should see them. It would be frustrating if shirt sizes are put in alphabetical order, because then you would have large, then medium, then small, then extra large. And that would be a little bit annoying if the clothing was arranged in alphabetical order or something like that, right? And so, in this case, these are not going to be put in alphabetical order, but they would be arranged in these things. Okay, these other things are the measurements of the size of the diamond, like the depth in the table is like how wide and how deep the diamond would. Anyway, but these are some of the different variables. So what we might do, and this is a very big data set. We have close to 54,000 entries in our data set. And we might say, hey, you know what? Let's just create a bar chart based on the cut. Okay. And so ggplot goes through, or R goes through, and looks at all kind of 53,940 rows, close to 54,000 of them, counts how many times it sees fair, counts how many times it sees good and premium and very good. And again, because cut is an ordered variable, the values appear in the order, in the kind of specified order. So it's kind of intrinsic to that variable. So rather than putting it in alphabetical order, it shows up in the order that makes sense, with fair, then good, very good, and premium and ideal being the best showing up there. And we have the counts, and just kind of coincidentally, there are more ideal cut diamonds than anything else, and the fewest amount of fair cut diamonds there. Okay, and so here you can see the only variable that we have mapped is cut. Okay, and here we're using geom_bar, and geom_bar basically tells R that you want columns, but you want R to figure out the height of the columns for you by counting up those values. Okay, here I can add a variable like fill. Okay, fill equals color. And so now we have different color gradings, D being the best and J being kind of the worst. And you can see all it has done, the default again is kind of stacked here. And so it just has taken this, but it has split each of these things up. And so it's kind of tough to tell anything really useful from this, other than it just adds kind of some colors and makes it a little bit prettier. And because it's hard to tell, like, are there more D ideal diamonds than D premium or D very good or things like that? And you know, what's the proportion of these things? And all you can see is that, yeah, you know what, every kind of color gets represented, D, E, F, G, H, I, J. You know, it's kind of tough to tell, but you can just see, like, okay, yeah, each of these things, the different colors are represented. If you know, I think it would be interesting if like one of these things only had like 2 of the colors, and then you'd want to draw attention to that. But here you can just say, like, yeah, you know, each of the cuts has different kind of things. Okay, now you can also for the position, okay, under geom_bar, you can do position equals dodge. So rather than stack them, you can put them all kind of side by side. So now you lose a little bit of like the total. So here the total height of the bar is like how many ideal cut and how many premium and very good and good and fair. So you lose a little bit of that. You know, it's still kind of, it's a little bit preserved, and you can see kind of like these bars, you imagine in total there it's going to be taller and things like that. Here we now start to see kind of like an interesting distribution that the values in the middle, you know, F, G, H tend to show up more than the values on the end, the J and D and things like that. So you kind of see this almost like a normal distribution is not quite right, because it's not numeric. We just have kind of like an ordinal variable, but going from D, E, F, G, H, I, J, you kind of see like, you know, D is less rare, but it seems like J is even more rare and things like that. And there seems to be more kind of like F and G. And then, you know, as the colors get worse, you know, there's fewer H, even fewer I, and even fewer J. And that kind of pattern seems to hold up. So that's interesting, and this is something that shows up. And here, all we've done is we've added position equals dodge. Okay. Here I've done position equals fill, and so now again, back here you can see there's more ideal cut, far more ideal cut diamonds than fair cut diamonds. When you have position equals fill, all of them add up to 100%. Okay. And so here what you see is between good, very good, premium, and ideal, the proportions are fairly consistent, I would say. Okay, with fair being kind of the one that's quite a bit different. But if you look at the proportion of diamonds that have D color, this proportion is fairly consistent across the board. If you look at the proportion of diamonds, so we're just kind of like looking at the thickness of each kind of thing, and you can see E is pretty consistent across the board. For whatever reason, for premium, it's you have a little bit fewer E than everything else, but kind of the thickness of that is fairly proportional. Whereas you can't really tell. Like here it looks like around, if this is 75% and 100%, looks like maybe around 12%. Consistently around 12% of diamonds are D for a good, very good, premium, and ideal. Whereas that's hard to tell. That's hard to tell that this is all 12%. 12% of this column is D, 12% is this to D, 12 is D, and 12% is D. That's kind of tough. It seems like fair cut diamonds, not very many D grade diamonds and things like that. But similar kind of proportions across the board. So that's something interesting when you use position equals fill to. So again, these examples show you like some of the things you can do, but also some of the things to pay attention to when you create plots. Okay. Here I have put color along the x-axis, and we have put the cut as the fill color. And so you can see we have fair, good, very good, premium, and ideal. And you can see, across the board, ideal is the tallest one. And we seem to have more kind of G color than anything else. But yeah, it's kind of a little bit tough to really make too much sense out of this bar. I would say this is probably not the best arrangement there, but that's what we have. Okay, and then our last section, I just want to kind of show you some examples using line graphs. Okay, and I guess before I go on, let me give you your third view quiz answer. Third view quiz answer is the letter C. C as in cat. C as in cat. Okay, so with geoline, it's much like having a scatter plot, except the dots get connected. Okay, so with geom underscore line, the dots get connected. So here, one variable is time and another variable is demand. It's just some values here, and so we're going to put one of these variables on the x-axis, the other variable on the y-axis, and so basically these get created as plot points. Okay, except those points, rather than dots, they get connected with a line. Right, so it's similar to drawing a scatter plot where you have kind of a numeric x value and a numeric y variable, but they get connected with a line. So it makes sense for things that have like a time series, okay, where you want to show not just these things are unrelated, but you want to kind of connect them, okay, to say there's some kind of path along there. Path is another option. So you have geom underscore line and geom underscore path, okay, and if the data are arranged so the x values are in increasing order, geom line and geom path are going to be the same. But if they're not in increasing order, then they are different. Okay, so geom path will connect the lines in the order that they appear in the table. okay? Whereas, this one should say geom line connects the line based on the increasing x variable. Okay, so here I have my table rearranged. I have, notice my time goes 1, 2, 5, 4, 3, 7. 1, 2, 5, 4, 3, 7. So if I do geom path, okay, as far as the x variable, okay, the lines will get connected from 1, then 2, then 5, then 4, then 3, then 7, okay? Whereas geom line, okay, is always going to draw the x in increasing order. 1, 2, 3, 4, 5, 6, 7. Okay, so, or actually there was no 6. The original data is 1, 2, 3, 4, 5, 7. Okay, so geom line always connects the dots in increasing order of x. So even if it's arranged like this, okay, 1, 2, 5, 4, 3, 7, it's always going to draw the line basically from left to right. 1, 2, 3, 4, 5, 7. Okay, whereas over here with geom path, it draws the line, it connects the dots in the order that they appear in the table. So 1, 2, 5, 4, 3, 7. So 1, 2, 5, then 4, then 3, then 7. Okay, the coordinates, like if we just drew a scatter plot with dots, the dots would be this in the same position for both of these things. But how the line is connected differs. And I apologize. This should say geom underscore line. Connects the line based on increasing x, and geom line will never kind of quote go backwards, whereas geom path you can go kind of backwards because it goes 1, 2, 5, then 4, then 3, then 7. Okay, so you have geom line and geom path. If the x is already in order, then line and path will show up the same. You can also draw multiple lines. Okay, and so we can have multiple lines with different kind of colors or different lines. And so here, this is a just some, I don't know what this data set is, but apparently somebody measured how much the teeth grew in guinea pigs based on whether they were given orange juice or vitamin C. And so I don't know what kind of experiment this was, but apparently they were looking at guinea pigs and they were measuring how much their teeth grew. And so in our data set, we have the guinea pigs that were given orange juice, and they were given different amounts of orange juice. We had dosage of 0.5, a dosage of 1, and a dosage of 2. And then we measured how much their teeth grew. And then we have the guinea pigs that were given vitamin C, and they had different doses of vitamin C, 0.5, 1, and 2 as well. And we measured how much these their teeth grew. I don't know this experiment, but anyway, this is what we have. So let's plot this out. Okay, so what we'll do is we'll put dose along the x. So we have 3 doses, 0.5, 1, and 2. And then we have the amount that the teeth grew, the length, okay, show up over here. And then we'll have the line colored by whether they got orange juice or vitamin C. So orange juice and vitamin C, we can see the teeth grew more for orange juice and vitamin C at doses of 0.5 and 1. But then when dose was 2, then they grew the same amount of 26.1. Okay, so that's what we have. So we have x on dose or length on y, and then the supplement. Okay, whether the supplement was orange juice or vitamin C, it determines the color of the line. Okay, when you print, you might print in black and white, and you might not be able to print different colors. And so in that case, you can choose different line types. Oh, here is an option where you can change the line thickness. So line width, here I have line width is 2. You can also map it to some kind of variable if you want to show that like different, I don't know, different points you can have a thicker line or a thinner line or something like that. Here I just have the lines being drawn thicker. And then here, instead of line color, you can have a line type. Okay, and so here you have a solid line versus a dotted line to indicate whether they got orange juice or vitamin C. Okay, that's it. This is just kind of a brief introduction to some of the other geometric objects that we can draw in ggplot. The column geometries, which are useful for creating bar charts or bar graphs, and then the line geometries, which kind of show these connected paths as well. Okay, appreciate your flexibility in watching the video recording for today, and I expect to be back in person on Friday, and so we will see you on Friday.